Hello everyone. In this video we're going to look at another example on calculating mean and variance of linear combination of multiple random variables. Not only one random variable but a linear combination of multiple ones. So in this example it says a company has 3 departments. Each day each department ships one package of random weight. So the weight seems to be a random variable. Let x sub I denote the weight of the package shipped by department I. And I is 1, 2, and 3. They've got 3 departments. X1, X2, X3 shows the weight of their package. Historical data suggests that the weight of the 3 packages are independent and they're here. So it looks like the distribution of the weight coming out of these 3 departments is normally distributed with these 2 parameters. And you remember for normal distribution, the first parameter is mu and the second one is sigma squared. Compute the mean and variance of random variables represented by each of the following. Part A, total weight shipped on a given day. Part B, the average weight per package shipped on a given day. So part A and B are both a linear combination of x1, x2, and x3. Part A is pretty simple. It says total weight. Well, total weight shipped out is the summation of x1, x2, and x3. So basically in this case, our linear combination is x1 plus x2 plus x3. Average weight, on the other hand, is basically average of x1, x2, and x3. So in that case, your y is x1 plus x2 plus x3 divided by 3. That's the average weight. Now, in order to calculate the mean and variance of y for part A and B, we need to know those C values, those coefficients, right? In the case of part A, we know them. Those are just 1. 1 times x1, 1 x2, 1 x3. But what are those values for part B? Well, if you look at this linear combination, it's really 1/3 of x1 plus 1/3 of x2 plus 1/3 of x3. So the C values or those coefficients are just 1/3. Well, the problem is almost solved, right? Because as long as you can figure out the linear combination, then the rest is just simple math. So for example, for part A, expected value of y is just 1 times the expected value of x1 all the way to x3, and expected value of x1, x2, and x3 are 10, 20, and 14. So we need to add them up. 10 plus 20 plus 14 gives you 44. That's the expected value of y. Variance of y is 1 times variance of x1 which is going to be, variances are 1, 9, and 4, right? So 1 plus 9 plus 4, that is 14. So now we know the expected value and variance of y. For part B, it is the same process, it's just it's 1/3 instead of 1. So I'm just going to write down the calculations. So this is how you calculate the expected value and variance of a linear combination.